TCP/IP Basics, Part 2, Counting in Binary. In this video, we're going to talk about binary numbers, and we're going to learn the basics of counting in binary. In decimal numbers, as we count up from 0 through 9, we're using the 10 different digits that we have. When we get to the 9 and add 1, we've not got another digit to use. So what we do is we generate a carry into the next digit to the left, and we start over in our counting. So we would go 8, 9, 10, which is our 1, 0. Well, even with larger numbers, we repeat the same process. Now, we typically don't show leading zeros when we work in decimal. What we're going to find is working in binary, we will show those leading zeros. If we're counting as digits get larger, if we've got 999 and add 1 to it, well, in the ones bit on the rightmost, the 9 plus the 1 gives us a 0 with a carry. That carry is added to the next 9, generating another 0 with a carry. Well, that repeats in the third 9 in this example, and we end up going from 999 to 1000, adding an additional digit. And we would keep this, and as we go, we can generate as large a numbers as we need to. With binary numbers, instead of powers of 10 for each digit, it's a power of 2. So looking at the powers of 2 in decimal, we went from 1 to 2 to 4 to 8, doubling each time, unlike decimal numbers when we increase by a power of 10 each time. When we count in binary numbers, and I'm showing the leading zeros because that's typical when we work with binary numbers, we go from 0 to 1 to 1 0, 1 1, 1 0 0, and so on. Now, if we start adding and looking how that works, we started with a 0 and we add 1 to it. So 0 plus 1 gives us a 1. Then if we add 1 to that, 1 plus 1 generates or gives us a 0 with a carry. So the carry moves over into the next bit to the left. Now we add an additional digit or number, 1, and so 1 0 plus a 1 gives us a 1 1, and we could continue that way. Now, here let's look at some examples. In the first example, we have a 1 0 0, and we're adding a 1 0 to it. Well, 0 plus 0 gives us a 0. The 0 plus 1 gives us a 1, and the 1 plus 0 gives us a 1, giving us an answer of 1 1 0. Well, the next example, we've got a 0 plus 1 generating the 1. Then we've got two 1s. 1 plus 1 gives us a 0, but there's a carry. Well, when we look at that carry, the 1 in the carry plus the 1 in the first number plus the 0 in the second number, well, 1 plus 1 gives us a 0 with a carry, and so that carry goes over into that leftmost bit, giving us a 1 0 0 1. Now, in the next example, we've got 1 plus a 1 1, so 1 plus 1 in the rightmost bit gives us a 0 with a carry. The carry plus the 0 at the top gives us a 1, plus another 1 gives us a 0 with a carry, and then that carry moves over to give us a 1 0 0 for an answer. The next one, we've got a 1 0 0, and we're adding a, well, I just noticed that that's the same as the one example above it. So much for cut and paste. Well, let's move on to the next. Here we've got a 1 0 1 0 adding to a 0 0 1 1, and when we add that, starting again the rightmost bits, 0 and 1 gives us a 1. A 1 and 1 gives us a 0 with a carry. Well, a carry added to the two zeros gives us a 1, and then we've got the 1 in the most significant bit. For the last example, we've got a 111 added to a 11, so we've got a 1 and a 1 gives us a 0 with a carry. Well, the 0 plus a 1 gives us, or I'm sorry, the carry plus a 1 gives us a 1, or a 0 rather. Let's try that again. A carry with a 1 gives us a 0 with a carry, plus 1 gives us a 1, and then in the next digit we've got the carry plus a 1 gives us a 0 with a carry. Add the 0 to it gives us the 0, and then the carry in the rightmost bit gives us a 1010. Now, next time we will look at converting decimal numbers into binary numbers.